Welcome to Math Study Tutorials, and in this video we're going to be looking at vectors part 3. Now if you've not watched part 1 and part 2, do well to watch it so that I have a clear understanding of what we're going to be doing in this video. Now before we go in, what we're going to be doing in this video, we're going to be looking at summing vectors, orthogonal and orthonormal sets, differentiation and integration of vectors with respect to a scalar variable, as well as determining equation of normal and the equation of a plane that passes through 3 points. That's a 3D plane, right? So we're going to take this question. For those that have watched part 1 and part 2, I want you to attempt this question. The cross product of 3i and 4k, right? The cross product of 3i and 4k. That's very simple to do. If you've watched the other parts, that's going to be 3i plus 0j plus 0k. That's vector 3i. And then for the other vector 4k, we could write it as 0i plus 0j plus 4k, right? And then if we place it I, negative j, and then k, and then that's going to be 3, 0, 0, and 0, 0, 4, right? So we're simply going to close the I, and then attend to the others, and that's going to be 0, 0, 0, 4, I, and then negative, and then we're going to close the j part, and that's going to be 3, 0, 0, 4, j, and then positive of, we close the k part, right? That means we're closing this, and that's going to be 3, 0, 0, 0, and then k. And then getting this, we're going to have 4 times 0, that's 0, negative 0 times 0, that's 0i, negative 4 times 3, that's going to be 12, right? And then 12 negative 0 times 0, that's going to be 12, right? J. And then plus 0 times 3, that's 0, negative 0 times 0, and that's 0. And then we're going to have is 0k. That's same as saying negative 12j, and that's the cross product. I hope that's what you got. Right, so we're starting off with summing vectors. Right, summing vectors, and I'll use the case of a position. Right, we're looking at position vectors. Right, and let's say we're looking at the vector A, and then the position vector, we could say that's OA. So let me have this line, right, and then this is the origin. Pay close attention. And then I'm looking at a vector, let's call it P. And I'm looking at another vector, let's call it Q, right? Let me clean this off, let it be along the line. I'm looking at another vector Q, right? Pay close attention. This is just to help you understand how to sum vectors. Now, if we take this down, this is vector P, which is OP, and then OQ, right? And OP is the position vector, OQ is the position vector of Q, right? So if we want to get PQ, what are we going to have? We're going to have negative OP, right? Because if we want to have PQ, it has to go this way, P to O, and then from O to Q. But you can see P is right from the origin down, that's the P vector. But we need PQ, so that's negative of OP, and then plus OQ, that's from P to O, which is negative OP, and then plus OQ gives us PQ, right? And then that's going to be OQ negative OP. So that leads us to a conclusion that if you have two vectors and then you're looking for, let's say, AB, to get the value of AB, it's simply the difference between B, that's B negative A, that's the position vector of B negative the position vector of A. Same here. So we're looking at PQ, what we're having is going to be the position vector of OQ, negative OP. And then we could use the small letters to represent these position vectors as Q and then negative P. So this is very crucial so that you understand when we are now summing vectors together. Let's say you're asked to sum this set of vectors. Let's say you have PQ and then negative TQ and then PS and then you have PT. This question was called from the CA of this course, right? The continuous assessment paper booklet for the course. So all you're simply going to use here is using this idea of that fact that PQ, if you have a vector PQ, the position vector is in relation to P and Q. We could now write PQ as what? Q negative P, right? And then remember we're adding it, and then plus we have a negative, right? So negative TQ. What's TQ going to be? It's going to be Q minus T, right? And then plus PS, and that's going to be S minus P, and then plus ST, and that's going to be T negative S. So resolving everything, we're going to have Q negative P plus, and then negative q, negative of negative is positive, right? And then that's a positive t, then plus s negative p plus t negative s. So s and negative x, s goes, right? And then we're going to have q negative p, and then plus you're going to have negative q positive t, then negative p plus t. So negative p, that's q and negative q cancel, and then we have negative p, and that's going to be negative 2p, and then t plus t is going to be 2t. So you can see that you can factor out 2 here, and then that's going to be negative 2 into what, right? Negative 2p divided by negative 2 is p, right? And then positive 2t divided by negative 2 is going to be a negative t. So I've factorized it, right? So based on what I said, we have that p negative t is going to be same as negative 2 of tp, right? Tp is going to be equal to t, sorry, yeah, that's true, that's negative t cp, right? And tp is going to be same as p negative t, right? So negative 2 tp. So if we have negative 2 tp, it's same as 2 pt because it's the opposite direction. So if it's negative, we could change it to a positive by changing the direction, right? Just like if we have op, and then if it's in the opposite direction, we could have it as negative of op. So negative of 2tp is same as 2pt, right? Understood? So that's the sum. So I want you to attempt this question. You could pause the video and then attempt it. So if you're asked the sum ya xy negative zy and zx, I want you to pause the video based on what I've explained. Do well to attempt it and get it. So what I'm simply then going to have here is ya, that's going to be a negative y, and then plus xy is going to be y negative x, and then plus, very careful with negatives, and then there's going to be negative of zy, and zy is going to be y negative z, and then plus zx, which is going to be x negative z. So resolving with negative y and positive y goes, we have a negative x, and then negative y, negative of negative z is going to be positive z, then plus x negative z. So z and negative z cancel, and negative x and positive x cancel. Then we have a negative y. So these are the position vectors, a negative y. So a negative y is going to correspond to ya. Ya is same as a negative y, which corresponds a the position vector of a, and y the position vector of y, right? So that if we have ya, right, if we have this as o, and then let's say this is going to y, and then let's say this is going to a, and then we're looking for ya, that's in this direction, is going to be negative y, right? Negative y, it has to go this way and then move down, and then a positive a, and that's same as a negative y. You get that? So that's it. Okay, so next we're going to be looking at orthogonal. And so that tells you that any question you're asked to solve, you should be able to do it, understanding it in terms of these position vectors. If you have st, you know you're talking about c minus s. If you have rs, you know you're talking about s minus r in terms of these position vectors, right? So you're going to be looking at orthogonal and orthonormal sets. That's another important concept to take note of in this stuff. So first of all, starting with the orthogonal, it's important to know that when we're talking about orthogonal sets, let's consider a set S equal to, that has two members v1 and v2. So this set that contains two members v1 and v2 is said to be orthogonal if v1 dot v2, which represents the dot product or the cross product of v1 and v2, is equal to 0, right? I know that if you've watched the previous video, you see that if we have two vectors and their dot product is 0, that means they are perpendicular. And we related the term orthogonal to what's perpendicular. We said that if you don't use the term orthogonal, you could use the term perpendicular, right? So v1 and v2 are going to be perpendicular. So let's say we have something like this now, a sample vector like this. let's say we have 1, 2, negative 1, and 1, negative 1, negative 1, right? So let's say we have a set 1, 2, negative 1, 1, negative 1, negative 1. So the question is this, sorry, excuse me, is this an orthogonal set? You simply do what? This contains two elements, right? So you simply check for the dot product. So 1 times 1 is going to be, that's 1 into 1, and then plus, that's component by component, 2 times negative 1, and then plus negative 1 times negative 1, right? So 1 times 1, 1, plus 2 times negative 1 is negative 2, and then negative 1 times negative 1 is going to be positive 1, and then 1 negative 2 is negative 1, and negative 1 plus 1 is 1 negative 1, which is 0, right? So that tells us that this set of 1, 2, negative 1 and 1, negative 1, negative 1 is an orthogonal set. But let's say that this set has more than two elements, right? So v1, v2, down to, let's say, vn. So how do you know if this set is orthogonal, right? So if we pick any two vectors from this set, vi and vj, all possible twos that we could get from this set, vi dot vj, where I is not going to be equal to j, and ij is going to be equal to 1, 2, 3 down to n for all n, right? So what this is trying to say is that if let's say we could make it up to 3, because if we, let's say we have three vectors, v1, v2, v3. So what you're simply going to do is that for all possible 2's that you could pick from this vector, their dot product is going to be 0. So if you pick v1 and v2, it's going to be 0. If you pick v2 and v3, it's going to be 0. If you pick v1 and v2, it's going to be 0. So for all the possible 2's, for all the possible pairs you could pick from the set, their dot product must be 0. So let's say that v1 dot v2 is 0, and v2 dot v3 is 0, and that v1 dot v2 is not 0. This set is not orthogonal. So for all i's, all j's that exist, they have to respect that, right? So let me give an example. Let's say we have this set 1, 1, 1, 1, negative 2, 1, and then lastly 1, 0, negative 1. So the question is this set orthogonal or not? So all we simply need to do, we're going to pick these two vectors, this with this, this with this, and then finally this with this, right? So picking this and this, A, B, C, right? A, B, C. So the dot product of A and B is going to be what? 1 times 1 plus 1 times negative 2 plus 1 times 1, right? And that's going to be 1, negative 2, and then plus 1, which is going to be minus 1 plus 1, and that's 0, right? And then if we pick B and C, what's it going to be? 1 times 1 plus negative 2 times 0 plus 1 into negative 1. And 1 times 1 is 1. Negative 2 times 0 is 0, and 1 negative 1 is negative 1. So 1 negative 1 is going to give us 0, right? And then if we then pick A and C, it's going to be 1 into 1 plus 1 into 0 plus 1 into negative 1, and that's going to be 1 negative 1, which is still going to be 0. So for all possible 2's, just like if you have 3 people, right? If you have 3 people and then you now want to select 2 from them, right? So there are 3 possible ways of selecting 2 people from 3 people, alright? And for all those possible combinations, those 2 must give you a dot product of 0. That is what implied by an what do you call it, an orthogonal set, right? So most of the time it may actually be restricted to 3 vectors, right? Because if we then increase the number of let's say it now has 4 vectors, we now have a v4, we are now going to increase the combination, because if we have 4 vectors here and we are now looking for the possible pairs that we could get so that we test their dot products, right? It's going to be 6, because it's just like a 4 combination 2. So from the 4 we are choosing 2, and that's 6 ways. So that's 6 possible combinations. We have to test 6 different situations, right? So it may just be limited to 3, or if it's limited to 4, you list out all the possible pairs of vectors you could get from the set given, right? And then you ensure that their dot products equal 0. Understood? Right? So for the orthonormal sets, very important concept. So when you say that a particular set given is orthonormal, first of all, if you consider a set as containing v1 and v2, this set is said to be orthonormal if, number one, v1 dot v2 is going to be equal to 0, which implies that first of all, this set is actually going to be orthogonal, right? And then secondly, the magnitude of v1 should be equal to the magnitude of v2 and should also be equal to 1. So magnitude of all the members of the set is going to be what? It's going to be 1, and also they're going to be orthogonal, meaning that their dot product is what? Is going to be 0. So even though this set has more than 2 members, right? So let's say it has v1, v2 down to vn, right? So we will now test for orthogonality, right? We pick all possible pairs of vectors from this set and ensure that their dot product is 0. That now tells us that, okay, this is an orthogonal set. Then moving on to see if each member has a what do you call it, a magnitude of 1, a magnitude of 1, v1, v2, v3 down. So for an orthogonal set, let's say we have s equal to v1, v2 down to vn, right? Vn is going to be equal to, let's say vk is going to be equal to 1 for all k equals 1, 2, 3 down till n, right? So from 1 down to the end. So the magnitude of v1, v2 down to the last member of that set must be 1. That is the condition. So first, the two or the set must be orthogonal, and then each member must have a magnitude of 1. For example, let's say this 1, 0, 0, 0, 1, 0, and then lastly 0, 0, 1. So first of all, you can see here that this set is actually orthogonal, because for every 2 we pick, if we pick this and this, if we pick this and this, and then if we pick this and this, right? If we pick this and this, it's going to be 0, 1 times 0, 0, 0 times 1, 0, 0 times 0, that's going to be 0. That's right. If we pick this and this, same, 0. If we pick this, that's 1, 0, 0 and 0, 0, 1. Dot product is still 0. Then if we check the magnitude of each, which is going to be the square root of x squared plus y squared plus z squared, is going to be what? The square root of 1 squared plus 0 squared plus 0 squared, the square root of 0 squared plus 1 squared plus 0 squared, and lastly, the square root of 0 squared plus 0 squared plus 1 squared, which all gives 1, 1, 1. Another example is that of, let's say, 1 over root 2, a set of 1 over root 2, 1 over root 2, 0, and we have 1 over root 2, negative 1 over root 2, 0, and then lastly we have 0, 0, 1. So this set is orthonormal, right? It's an orthonormal set, and for it to be orthonormal, first of all, it's going to be orthogonal, right? Because the dot product, if we get the dot product of, let's call this A, B, C, if we get the dot product of this and this, 1 over root 2 times 1 over root 2 is going to be 1 over 2, right? And then 1 over root 2 times negative 1 over root 2 is going to be negative 1 over root 2. And then plus 0 times 0, and that's going to be 0. So 1 over root 2 times negative 1 over root 2 is going to be negative 1 over 2. And then that's going to be 0. And then plus 0, that's 0. And then if we take the dot product of B and C, it's also going to be 0, same, because 1 over root 2 times 0 is 0, negative 1 over root 2 times 0 is 0, and then 0 times 1 is 0. So dot product is 0. And then if we take the dot product of A and C, it's still going to be 0. So first of all possible pairs of vectors that could be taken from the set on the screen, right? Dot product is going to be 0. And then the magnitude is also going to be equal to 1, right? So if we get the magnitude of A, it's going to be 1 over root 2 all squared, then plus 1 over root 2 all squared, and then plus 0 squared. And that's going to be 1 over root 2 all squared is going to be 1 over 2 plus 1 over 2 plus 0. And that's going to be square root of 1, and that's 1, right? And then same applies to this, same applies to this. This magnitude of 0, 0, 1 is still 1, right? So that's an orthonormal set. So with all I've explained, I hope you should be able to identify an orthonormal set. Now, the next thing we're going to move to is differentiation and integration. Differentiation and integration of vectors with respect to a scalar variable. Right? With respect to a scalar variable. So this is quite easy, right? You just have to understand, first of all, master differentials. If you've not watched my video on derivatives part 1, you can do well to watch it so that I can refresh your memory on how to get the derivatives of basic functions, right? So let's say we have a vector rt, and this is kind of like a position vector r, and then with respect to a scalar t could be any scalar, and then we have three different components. Remember when I was talking about the different dimensions? We have the 2-dimensional vectors and the 3-dimensional vectors. And 3-dimensional, let's say we are ending there for now in this course, and then we're looking at the xyz, which tells us that this is a 3D, or we could represent it as xi plus yj plus zk. If you watched part 1, you'd have seen where I explained 2D and 3D vectors. So rt is going to be a function of 3 different coordinates, and that's going to be xi plus yj plus zk. But this is not complete because each of them has to be a function of this scalar, right? Because the scalar is acting. So we can then write it as x of ti, and then plus y of tj, and then plus z of ck. So that relates to this. So r of t is going to be equal to x of ti plus y of tj plus z of tk, right? So the differential of this vector r with respect to the scalar t is simply going to be dr over dt can be equal to dx dti plus dy dti, and then plus dz dtk. Okay, dy dtj, sorry. Okay, dx dti, dy dtj, and dz dtk, right? And it's important to know the differential rules that work here, right? And number one that I will tell you is the fact that if you are differentiating a given vector function that has a scalar variable in it, and then maybe one of the terms, right? One of the terms just has a constant. That is trying to tell us that dk, d of k dt is going to be equal to 0. If you've watched my video on derivatives part 1, we mentioned that the derivative of a constant is 0. So let's say I'm given a particular vector function that has a scalar variable that's with respect to a scalar, and let's say it's saying 8t squared I, and then plus, let's say, 6tj, and then let's say minus 8k. So if you are differentiating, let's not look into this right now. This one's contain t, but you can see that this is just a constant, which is negative 8. No t is attached to it. It's just a constant. So if you are differentiating this segment, it's just simply going to be 0k, right? 0k. So do you understand? So it's a constant, so differential is going to be 0. So moving on, the next thing here is that if you now have a constant and then is now attached to a function of t, let's call that function u. So that's d of k u t, and then all over dt is going to be equal to k of du over dt. Just like this example I gave now, where we said that if we have rt to be equal to 8t squared, then let's say negative 60, that's 8t squared I, negative 60j, and then negative 8k. And I asked for dr dt. What's it going to be? So this 8 now is a constant. What this stuff I wrote over here, where I said that d of k of ut over dt is equal to k du dt, we can simply bring out the 8, which is the constant here, and then we simply differentiate the u function, which is in this case t squared, And if we differentiate c squared, if you know the general convention for differentiating a function in the form x to the power n, you know what is it, right? It's going to be nx to the power of n minus 1. So for t squared, what's it going to be? 2 comes down, it becomes 2t to the power of 2 minus 1, right? So that's 2 minus 1, that's 1, and that's 2t. So that's 8 into 2ti. Then we apply the same thing here, right? So this is negative 6. So we take out the constant, which is negative 6, and then differentiate the u function, which is the du dt. So in this case, u is t. If we differentiate t, what's it going to be? It has a power of 1, right? So 1 comes down, right? So it becomes 1t to the power of 1 minus 1. And then that's 1t to the power of 0. And t to the power of 0 is what? It's going to be 1. Because, first of all, t is greater than 0, right? And it's not 0. 0 raised by 0 is not 1. All numbers raised to 0 is 1 except 0, right? So if we differentiate 6t, differential of t is what? 1. So we simply have what? 1. And then we attach the j. And then lastly, for the negative 8k, I mentioned it when I stated the first theorem that said d of k dt is 0, right? D of k dt, and this is not because of, don't associate, this is k, which is representing that's the third dimension of this 3D, but the k that I'm implying in this first theorem is talking about a constant, right, which is this negative 8. This negative 8 is the constant, but it doesn't have any t attached to it. That's why it's a constant, so it's going to be 0. So even though we had RT, let's say RT was actually 19i negative 18t squared j. Let's say we had a function like this and you were asked in the exam to get the value of the RT. What's it going to be? Since 19 is a constant, it does not have any t function attached to it, right? So it's simply, we are going to differentiate it out to be what? 0i, because this is a constant and there's no t variable attached. And then by the time we differentiate this, it's going to be what? 2 comes down, right? So it becomes negative 18 into 2t to the power of t to the power of 2 minus 1, and that's negative 36t. So 0i negative 36t j. Do you understand? So this k is not the k of the xi plus yj plus zk, but the k that represents a constant. Understood? So for the third theorem I'm going to give you, all this relates to the product rules that I've been doing, right? If you have the differential of the cross product u dot v over dt, just like in the product rule of differentiation that said that if we have a product of uv and then dt, it's simply going to be v du dt plus u dv dt. So in this case, same applies. It's going to be v dot du dt plus u dot dv dt. And you know, addition is commutative, right? So you can decide to say u dot dv dt plus v dot du dt, and you get the result. Or if you are given a let's say vector u and vector v, and then you're asked to find d of u dot v over dt, all you can simply do is to get the dot product of u and v and then differentiate to make it easier, instead of getting two different dot products and then getting your answer. This is just something you should know. This is a property of these vectors. And then the same thing applies to cross products. If you have d of u cross v, or you know that this u cross v can also be written as u cross, this is another way of saying cross products, right, divided by dt is going to be equal to v cross du dt plus u cross dv dt. So to save stress, you can simply get the cross product of u and v and then differentiate, or understanding this theorem, which you should know, get v and then cross it with du dt and then plus u, then cross it with dv dt, and that will give you. And then we're going to take examples shortly. So also remember, so with the concept of the product rule, which is d of uv over dt will be equal to v du dt plus u dv dt. So let's go right into questions that could pop out from this concept. And it's the fact that when we are looking at vectors, now, and we're relating it to different, remember we talked about scalars in part 1. We talked about scalars and we talked about vectors, and we said that vectors, they are those ones that have magnitude and they also have direction, but scalars, they just have magnitude but no direction. But now we want to relate this r, which is a function of t, we want to relate it to a position vector. And this position vector, can also call it like a displacement vector, right? A displacement vector. So when we're talking about this displacement vector now, the question now we say, okay, this is a position vector of a particular particle on a curve, and then we now want to know the velocity at a particular time t, because we are now differentiating the function with respect to a scalar variable. But my main point here is we have rt. If we should have rt representing the position or displacement vector, right? The first instance I just give a general expression r of t. T could be any stuff, right? But if you are taking r of t to be a position or displacement vector, it's important to note that if you are to now get the value of dr dt is going to correspond to the velocity vector. Take note of this, because remember that velocity is what? The rate of change of displacement with time. So when we differentiate displacement with respect to time, we're going to get the velocity vector, right? So they could give you a function of rt, which is a position vector of a particular particle, and then ask you for the velocity vector of that. So all you simply need to do is to differentiate that position vector. Then another thing you could be asked is for the acceleration vector, which is going to be differentiating this position vector twice, right? Because if you want to get acceleration vector, acceleration is the rate of change of velocity with time. It's simply dv over dt, right? So if you have dv over dt, that means acceleration with respect to this position vector is going to be d squared r over dt squared. D squared r over dt squared. That means we are differentiating it again. That means we are differentiating, this is the vector, right? Which is the r dt. So if we should differentiate the velocity vector, we're going to get the acceleration vector, which is going to be the square r over the dt squared vector. Do you get that? So now let's solve questions. So let's say you are given this question now. This was one of the questions I got from the CA booklet, and the question goes this way. It says the position vector rt of a particle is given by r of t equals 3 sine 2t, 3 cos 2t, 2t. Find its velocity. Find its velocity. This is r of t. Let's say I ask this question in exam. The position vector rt of a particle is given by this. That is the position. If you're looking at the position vector, remember what I illustrated with the origin. This is O, and then we're looking at a particular vector. Let's call it A, depending on what that vector is. And then this is the position vector, which is also a displacement vector. So we now want to know what's the velocity, what's the rate of change of that distance as time is going on. Do you understand? So we have 3 sine 2t, we have 3 cos. This is 3. So remember that I said that if we have a 3-dimensional vector which is represented as x, y, z, we could also represent it as a column vector of x, y, z, or we could write it as xi plus yj plus zk. So all we are simply then going to have here is that r of t, which is 3 sine 2t, 3 cos 2t, so that I make everything same as all I've been saying from the beginning. We're going to have 3 sine 2ti, and then plus 3 cos 2tj, and then plus 2tk. And then according to what I stated earlier, for the value of dr dt, right, generally is going to be dx over dti over plus dy dtj plus z dtk, right? So we differentiate each component by component, part by part. So for the 3 sine 2ti, that's why it's important to know the differentials of these basic 3 identities. And I've already given you the basic one, function, derivative. For a function of x to the power of n, the derivative is simply nx to the power of n minus 1. And then for a cosine function, let's say cos x, the derivative is simply negative sine x. And then for a sine function, the derivative of sine function is simply a cos x, right? And then lastly, another important one that I've come across is that of the exponential function. The derivative of an exponential function is the exponential function itself, right? So e of x is also going to be e of x. Do you understand? Okay, so for 3 sine 2t, so this is the vector we have. We have 3 sine 2ti, and then plus 3 cos 2tj, and then plus 2tk. So if we should differentiate if we should differentiate 3 sine 2t, remember what I said, the second property I mentioned when I was explaining. I said that if you have d of kut dt, which is number 2 over here, we take out the constant, which is k, and then differentiate u. Take out the constant k and differentiate u. So in the case of 3 sine 2ti, the dr dt, which is going to correspond to the velocity vector. So we are going to take out 3 and then get the derivative of what? Sine 2t, right? So we're going to get the derivative, and then for cos 2t, we're going to take out 3 and then get the derivative of what? Cos 2t, and then take out 2 and get the derivative of what? T. So what's the derivative of sine 2t? What's the derivative of sine 2t? That's the question you ask yourself. So what I'm going to use here is literally something very clear. So let's divide this. So if we say let u be equal to 2t, that's why you should be able to master differentiation. If you can get the differential, just take out the scalar part and differentiate it accordingly. So if u is now equal to 2t, because 2t is a function and then sine is also another function. It's not just if it was something like sine t, okay, we would simply say differential of sine t is what? Cos t. But since we're not having 2t, we can't just go straight and say that the differential of sine 2t is cos 2t, because 2t is a function. The reason why maybe we are not seeing any effect is that if we have sine t is sine 1t, and differential of t is 1, so it's not actually making any impact. Do you understand? So if let u to be equal to 2t, and then du over dt, if we differentiate 2t, is going to be 2. So all we simply need to do is to multiply 2 by the differential of what? Sine. Since we say let u be equal to 2t, that means we can say that this is same as sine u. Are you following? Since we say let u be 2t, that means it's sine u. And if we differentiate sine u, what are we going to get? It's going to give us cos u. So the differential, because this is like it's just like saying y equals sine u, and then dy du is what? Cos u, and then dy du times du dt is going to be 2 cos u, right? And then we multiply by this scalar that is here, and then 3 times 2 is what? Is 6. That's 6 cos u. And all of this I got using chain rule. So if you don't understand derivatives, please do well to watch my video on derivatives, the basic parts. They are not asking us the complex derivatives, right? The basic parts: 6 cos u, 2 times 3, 6, and then cos u. Because if you differentiate sine 2t, you get the differential of 2t, which is what? 2, multiplied by what? The differential of sine u, which is the sine 2t, which is going to give us cos 2t, right? So that's going to be 6 cos 2t. And then for the other, the same applies. Differential of cos is negative sine. So that's 3 into negative sine. And then if you differentiate 2t, is going to give you 2, right? So negative sine 2t and then multiply by 2. And that's going to be negative 6 sine 2t. And then lastly, for 2t, if we differentiate t, what are we going to get? 1, right? And then 2 times 1 is going to be 2. So our final answer is going to be 6 cos 2ti, negative 6 sine 2tj, and then plus 2k. And this is the velocity vector. So let's say you were asked to get the acceleration vector. So what you now have to do is to differentiate this vector again. If you differentiate this vector, that's differentiate it, what are you going to have? Based on what I explained, differential of 2t is what? Is 2. So 2 times this 6, it makes it 12, is it not? And then differential of a cosine function is what? Is negative sine. So negative sine 2t. And then negative of 6. And if you differentiate 2t, what is it? It's going to give us what? 2. Multiplied by the differential of sine u. Let's say that let u be equal to 2t. Do you understand my point? So if you differentiate sine, it's going to give us what? It's going to give us a positive cos. That's cos 2t. And then if you differentiate 2k, right, you can see that this is like a constant. It does not have any t attached. So it's simply 0, because no t function is attached to it. Do you understand? And then what we're now going to have is negative 12 sine 2t, negative 12 cos 2t, and this is the acceleration vector. Do you understand? That's the acceleration vector. So it's as simple as that. So all of this relates to other questions that you could actually see. I would want you to solve this. When I run out the question, you can do well to attempt it. Right? So let's say that there's a question I saw. It says acceleration vector of a particle. Acceleration vector of a particle is given as A equals 12 cos 2ti. That's A is given by 12 cos ci, and then negative of 12 sine cj. And the question says find the magnitude of its velocity. So all you simply need to do here is this now takes us to what? Integration. This takes us to integration. So if you are looking at magnitude of its velocity, you know that is the differential of velocity that gives you acceleration. But if from acceleration you now want to get the velocity, you will now integrate, which is the reverse process. So that leads me to this table. So if you have a function and then you now want to get the integral of that function, what is it going to be? For x raised to power n, the integral is simply x raised to power n plus 1 divided by n plus 1. And then for cos x, the integral is sine x. But for sine x, the integral of sine x is negative cos x. So based on what we have, this is in terms of t. So if you differentiate cos t, it's going to give us what? It's going to be what? Over here. So let me write it out. A is given to us as 12 cos ci negative 12 sine cj. So we now have to integrate this 12 cos ci negative 12 sine cj with respect to what? That's dt. So we can now split it as integral of 12 cos ti negative integral of 12 sine cj, each of them bearing a dt. Are you following that? Nice. So with this now, what are we then going to have? So we can bring the constants backward, and then we have 12 integral of cos t I dt negative 12 integral of sine t dt, right? So what is this going to be? The integral of cos t is going to be what? Sine c, right? So that's going to be 12 sine ti, and then negative 12. The integral of sine is what? Negative cos, but the differential of sine is what? Positive cos. Take note. So negative cos t, and then j. So that's going to be 12 sine ci, and then plus 12 cos cj. And this is for t greater than or equal to 0. So even though we have this constant, a plus c, because after integration there's always a constant of integration. So even though we substitute a c and then we take t to be now equal to 0 to get the constants, what are we then going to have? The c is going to be 0, so we can take off the c, because according to the question, I didn't state the question out fully. It says that acceleration vector of a particle A equal to 12 cos ti negative 12 sine tj for t greater than or equal to 0. Find the magnitude of the velocity. So this is the velocity vector. So in order to now get the velocity, what is it going to be? You know how to get magnitude of vectors, right? So square root of each component, 12 sine t squared plus 12 cos t squared. And that's going to be the square root of 12 squared sine squared t plus 12 squared cos squared t. And then we can factor out, there's a common factor here, and that's going to be 12 into 12 squared into sine squared t plus cos squared t. And you should know the trig identity that says that sine square x plus cos square x is 1, right? So you can therefore say that sine squared t plus cos squared t is going to be 1. And that's square root of 144, which is going to be That's going to be 12. That's going to be 12, right? That's the magnitude of the velocity, 12 units. Okay, so that's it with respect to the acceleration vector that was provided, 12 units. If it's in meters per second, depending on what unit of velocity was provided. Okay, so lastly, we're going to take this question, and I want you to attempt the question. And now this question is based on, okay, two more questions by the way. So let's say this question says if r is going to be equal to xi plus yg, right, and x is equal to k into 1 plus cos t, and y is going to be equal to k into 1 plus sine t. The question said then d squared r over d t squared. Now it's asking you for the magnitude of d squared r over dt squared. So since the r vector has been given to us as xi plus yj, and x has been given to us as k into 1 plus cos t, we can simply substitute as k into 1 plus cos t, and then plus y. What is y? K into 1 plus sine t, and then j, right? And then the question now is, what is d squared r over dt squared? So that means we're going to get this, the r over dt first, right? So what's the r dt? What's the r dt going to be? So you can see that this is a case of differential of k u of t dt, which is going to be k du dt. So we can take out this constant k, because this k is a constant according to the question. So we take out k. What we are looking at is t, and then if we should differentiate 1 plus cos t, what's it going to be? Differential of the constant 1 is what? Is 0, and then plus, if we differentiate cos t, is what? Is minus sine t. I'm just mixing all this with integration so that you remember, if you integrate cos t, you get sine t, but if you differentiate cos t, you get negative sine t. And then plus, you take out the constant, right? And then if you differentiate sine t, what are you going to get? It's going to give you a cos t. That's going to be 0. Differential of 1 is 0, and then plus cos t j. So that's going to be, remember this has an I, right? This has an I, is it not? So that is k into negative sine t plus k cos t j. So k into negative sine t is same as negative k sine ti. Remember there's an I, and then plus k cos tj, and this is the r all over dt. So if you're now looking for the square r over dt square, which is the second derivative of the r function, that means we differentiate this, and if we differentiate this, we take out the constant. In this case it's negative k, and then if we differentiate sine t is what? It's going to give us cos t, and then we attach the I, and then plus k. We take out the k, and if we differentiate cos t, is going to give us what? Minus sine t j. So that's negative k cos ti, negative k sine tj. So with this now, the question asks for the magnitude, because this is the square r over dt square. This is the value, but the magnitude now is going to be what? The square root of negative k cos ti squared. Okay, sorry, that's k cos t squared, because we are taking the magnitude, right? Plus negative k sine t all squared. Because if we have a vector xi plus yj, the magnitude is going to be what? Square root of x squared plus y squared. We are taking the I and the j components. So if we square this, negative k all squared is going to be k squared cos squared t, and then plus k squared sine squared t. We can factor out k squared, right? So that's going to be square root of k squared into cos squared t plus sine squared t. And with what I said earlier, sine squared t plus cos squared t is what? 1. So that's square root of k squared into 1, which is square root of k squared. And square root of k squared is what? Is going to give us k. Are you following that? And then lastly, I'll take this question. I want you to pause the video and attempt this, and then we'll go to equation of normal and then 3D plane. So if it says that a particle moves along a curve with parametric equations x equal to e to the t, y equals 2 cos 3t, and z equals 2 sine 3t. And the question is asking you for the velocity vector. The velocity vector. So what is the velocity vector? So with the question now, x equals to e to the t, y equals to 2 cos 3t, and then 2 sine 3t. So this relates to the position vector of that particular time t, right? So velocity vector, we first of all write down the position vector as e to the power of ti plus 2 cos 3t, which corresponds to the y coordinate j, and then plus 2 sine 3t k. So the next thing is to get the velocity vector, which is to get the differential of the r vector. So if we differentiate an exponential, that's e to the t, is going to still be what? E to the t. But you know that if maybe the question, if it says e to the 2t, take note though, if it said e to the 2ti, you first of all have to differentiate this, because this is like function of a function, chain rule, right? So you differentiate 2t, you are going to get 2, and then you multiply it by exponent, by differential of e. Let's say 2t is equal to u. You say let 2t be equal to u. So if you differentiate 2t, you have 2, which is like the du dt, and then multiply by dy du. Because if you have said that e to the 2t, if you say that 2t is u, if you now differentiate e to the u, is still what? E to the u. And 2 times e to the u is what? E to the what? 2e to the power of what? U, which is 2e to the 2t. So you can see it to be different. So et, and then plus, you take down this 2, right? And then multiplied by, if you differentiate, if you take out 3t as u, differentiate 3t is going to give you 3 times 3 multiplied by, differential of course is minus sine, right? So that's going to be minus sine u, which is minus sine 3t. And then lastly for the k, and then remember to attach I, j, and then for this part, this is going to be 2, which is the constant, then times, if you differentiate 3t, we are going to have 3 multiplied by, differential of sine is what? It's going to give us cos, is it not? It's going to be cos 3t and then k. So finally, the velocity vector, which is the r dt, is going to be e of ti plus, okay, there's a negative here, so that's negative 6 sine 3tj, and then plus 6 cos 3tk. And this is the velocity vector. You get it? That is the velocity vector. Then lastly, we are going to look at equation of a plane. Equation of a plane passing through 3 points. I've seen some questions on this. But before we continue with this, based on all that I've solved, you know, I just solved one question on integration, right? Based on the fact that if you are given the acceleration and I ask for the velocity, all you simply need to do is to integrate the acceleration, you get the velocity. And I mentioned x to the power of n, cos of x, and sine of x. Also, the same applies to e of t, e of x, or e of t. Integral of e of x is still e of x. So you can be given a function, you should be able to integrate. If you are given acceleration and then you have to get the velocity, you integrate. If you integrate acceleration, take note, you get velocity. Then if you integrate velocity, you get the position vector. So that in case, if maybe you are given the velocity vector, I'll still solve questions, separate videos where I'll solve questions one by one. If you are given velocity vector and you integrate the velocity vector, you will get the what? Position or the displacement vector. So let's move on. So based on this equation of a plane passing through 3 points, we are looking at 3D plane. And if you watch the other videos, we are looking at x, y, and z coordinates. This is the z, this is the y, this is the z. And then we are now looking at a plane that's lying in this x-axis. Let me just bring it out. Let's look at the plane here. This is a plane. And then the question is, what's the equation of that plane that's going to pass through those 3 points? And then I'll explain very clearly. So if this is a clear plane, right? Let this be very clear. Sorry. So if this is a clear plane now, and then we are taking 3 different points. Let's call this point P. Let's call this point Q, and let's call this point R. So if we extend a, what do you call it? A kind of like a normal vector in this direction, right? I'm not drawing this perfectly because this is a 2D plane, right? So I may not be drawing it perfectly. But the point here is that we are looking at 3 different points that lie on this x, y, z coordinates. And this normal now, there's a normal that shoots out from the middle vector that is going to now be, take note, something like this. So it's gonna like make an angle of 90 degrees, kind of some way. I don't know how this will be clear. But such that it's now making an angle of 90 degrees with each of them. But based on their position, maybe you may not see clear this is a 2D and I'm not giving you a 3D representation of it. But my point here is that you're going to have 2 points, right? Let's say 3 points, A, B, and C. And the fact is that this is BC and this is BA. So if you take BC and BA and get the cross product, BA cross BC, we are now going to get the normal vector. Because if you watched part 2, I said that if you get the cross product of 2 vectors, let's say A and B, the output of that crossing, let's call it C. This C is going to be perpendicular to A, implying that C dot A is going to be equal to 0 and C dot B is also going to be equal to 0. Are you following? So if we get the dot product of 2 vectors where normal vector is shooting out, making an angle of 90 degrees with both BA and BC at the same time, that's what I'm trying to draw out here, right? But I may not get it perfectly. So BA, BC, with BC, do you understand this kind of thing now? This is kind of something they're having. It's making an angle of 90 with this because of where it's resting, and it's also making an angle of 90 with this. Let me call this A. Let me erase this because this is not making an angle of 90 degrees. It's just a sketch. So this is A, this is A, B, and this is C. So if the normal now shoots out of it, that's going to be perpendicular to A and C. We need to get the cross product of BA and BC to know that vector that will be perpendicular to both BA and towards BC. Are you getting that? So to get that is what will give you the normal vector. That is what gives you the normal vector. So now let's take this question. Equation of plane through the points. We have A as 2, negative 1, 1, B as 3, 2, negative 1, and C as negative 1, 3, 2. So if we have these 3 points, just choose any point of your choice, right? Even though we choose A, if A is now acting as the central vector from which the normal vector will originate, we're now going to check, let's say here is A, and then what we're going to take is AB and what? AR. AB and A, okay, AC. AB and AC. So we now get the cross product of AB and AC. And remember what I said about position vector. If you have AB, to get it is simply what? B minus A. And for AC is going to be what? C minus A. So for AB, what are we going to have? It's simply going to be B minus A. So each component of B, subtract it on the A. So 3 minus 2 is what? 1. 2 minus 1 is what? 3. And negative 1 of negative 1. Negative 1 minus 1 is what? Negative 2. That's for AB. And then for AC, what are we going to have? It's simply going to be C minus A. So negative 1, negative 2 is going to be negative 3. And then 3 negative of negative 1 is going to be 4. And then 2 negative 1 is going to be 1. So we simply get the cross product of the corresponding I negative jk of 1, 3, negative 2 and negative 3, 4, 1. And then all we simply do, we close the I, and then we're going to have 3, 4, negative 2, 1, I, then the negative of j, and then we close the j part, we have 1, negative 2, negative 3, 1, and then lastly for the k, we close the k part, and we have 1, 3, negative 3, 4, and then k. So if you get the determinant, this is going to be 3, and then negative of 4 times negative 2 is negative 8, and then that's I, and then negative of j, and then 1 times 1 is 1, and then negative 3 times negative 2 is positive 6. Are you following that? Positive 6. So negative 6, and then plus 4 times 1 is 4, then negative 3 times 3 is negative 9. So negative of negative 9 k. That will be 11I, and then 1 negative 6 is negative 5, and then negative is positive, so 5j, and then plus 4 negative 9 is going to be 13. Okay, so this is the normal vector. So whatever you get as the normal vector, so this is diagram now. So let's say this is the normal vector that shoots out of this. Let's call it n, and it's going to be perpendicular to this AB and also going to be perpendicular to this AC. Do you understand? So it's going to be perpendicular to this and also perpendicular to this. So with this now, if we should now choose any arbitrary point along AB, right? If you choose any point along this AB or along this BC, that's now what leads us to the equation of the plane that tells us that if we have a normal n, and then that normal is given by alpha I plus beta j plus gamma k, the equation of the plane is going to simply be what? Alpha into x, which is that arbitrary point, let's say along AB in this case now, x minus x1, and then plus beta x minus x2 plus gamma x minus x3. And why are we doing this? Because if we choose, we are not just looking at point B, point A, and we are also looking at points that lie between A and B, maybe this point or this point. So if this point is here now, this point now is going to be across this plane is going to be x minus whatever coordinate is here. Let's call it x1, and then this x minus x1 is going to be perpendicular to this normal vector, isn't it? And for two vectors to be perpendicular, their dot product is supposed to be 0. So all these things we are doing now is what? Cross product. We multiply this by the component of that point we are looking for, b by that component, and everything should be equal to 0 because it now has to be perpendicular. Each plane perpendicular to the normal. Each plane perpendicular to the normal. Or if we now decide to take from the other point, let's call it, in this case, AC. If we are now choosing from AC, we may now have that the AC vector is alpha of, that will be x minus x2 plus, okay, there's a little bit of confusion. This is x negative x1, and then this is y, this corresponds to the y vector, y negative y2, y negative y1, and then z negative z1, because we are looking at the x, y, and z plane, so sorry for that. And then for the beta, we have y negative y2, and then plus gamma of z negative z2, and then the same applies if we are now looking at the third point, maybe from the normal. We are not going to have that from the normal, which will still make angle of 90 with the other two. We're going to have x negative x3 plus beta of y negative y3 plus gamma of z negative z3, each of them with their corresponding x, y, and z. So no matter the one you choose, since they are perpendicular to each other, right, it will still give you the same equation. So for this case of 11i plus 5j plus 13k, we can pick any point that lies on this plane that we're looking for. For example, we can take 2 negative, which is the first point, 2 negative 1 1. If we take 2 negative 1 1, so we have 11i and then plus 5j and then plus 13k. This is the normal vector. So the equation is simply going to be 11 into x minus, remember we are taking the first point, which is a, 2 negative 1 1. 2 negative 1 1. 2 negative 1 1. So that's x minus x1. This is x1, isn't it? This is what? y1, and this is z1. So x minus 2 and then plus 5 into y minus y1, which is what? Minus 1, and then plus z, which is 13 into y negative 1, and all of this should equal 0. So on simplification, we have 11x negative 22 plus 5y, and then negative is positive, and then 5 times 1 is plus 5, and then plus 13y negative 13 equals 0. And then we have 11x plus 5y plus 13z. This is going to be 13z, right? Alright, so sorry. So this is going to be 13z, not 13y. This is x minus x1 plus y minus y1 plus z minus z1. Right? So z is z. And then plus 13z. And then negative 22 plus 15 is going to be negative 17, right? And then negative 17 negative 13 is going to be negative 30 equal to 0. So we can add 30 to both sides, right? So it becomes 11x plus 5y plus 13z equal to 30. Now this is another type of question you could see. There's a question I saw in the CA that said that you are asked for the equation of the plane through 1, negative 1, 2, and normal to 2i, negative 3j plus 4k. So if you have already been given the normal n, the n vector, which corresponds to alpha I plus beta j plus gamma k, all you simply need to do, you have been given a point on that plane and is also normal to it, right? So it's simply going to be alpha, which is 2 into x minus x1. In this case, let's call it x1, and then minus 1, and then plus beta. What is beta here? Minus 3 into x minus, what's the, sorry, y, because we are looking at the y components right now. So y negative of negative 1, and then plus z plus 4, right? The beta component, the alpha, that's the gamma component of the normal vector. That's 4 into z minus, what does this correspond to? 2. And then everything should be equal to 0. That will be 2x minus 2, and then plus of negative 3y, and then negative is positive, so negative 3 times positive 1 is still going to be negative 3, and then plus 4 times z, that's 4z minus 8 equal to 0, and that will be 2x minus 2, and then minus 3y minus 3 plus 4z minus 8 equals 0. And then we are then going to have 2x negative 3y, and then plus 4z, and then minus 2 minus 3 is minus 5. Minus 5 minus 8 is minus 13 equals 0. And that's 2x minus 3y plus 4z equals 13. So we just took the normal vector in the form of alpha I plus beta j plus gamma k. And then since we are given a point that passes through that plane, we then use the general form of alpha into x minus x1 plus beta into x minus y1 plus gamma into what? Z minus z1, and then substitute easily. So lastly, this is the last question on this. So let's say that P is 1 0 0 0, and then Q is 0 2 0, and that R is 0 0 3, and then we are asked for the plane, right? The equation of the plane that passes through these 3 points. What's it going to be? We can pick a single point, which is going to be our center of normal, So taking something like this, are you following that? So this is making 90 degrees, this is taking 90 degrees. Are you following that? And then this is the normal. So all we simply need to do, let's say this is Q and this is R. So we take PQ and PR and then get the cross product. So PQ is going to be what? Q minus P, right? So 0 minus 1 is minus 1. 2 minus 0 is going to be 2. And 0 minus 0 is going to be 0. And then what's QR? QR is going to be 0 minus 0, and that's 0. 0 minus 2, that's minus 2. And 3 minus 0, and that is... Okay. So what we're looking at now is PQ. So we subtracted Q from P. That's 0 minus 1, 2 minus 0, and 0 minus 0. And then for PR, not QR, right? You must be very careful. So for PR, is simply R minus P. So 0 minus 1, that's going to be minus 1. 0 minus 0, and that's going to be 0. And 3 minus 0, that's going to be 3. So we then get the cross product of negative 1, 2, 0. And that's I negative jk and negative 1, 0, 3. So if we close the I, what are we going to have? 2, 0, 0, 3 of I, negative. If we close the j, negative 1, 0, negative 1, 3 of j. And then if we close the k, we have negative 1, 2, negative 1, 0, k. Are you following? So 2 times 3 is 6. 6 minus 0 is going to be 6i. And then negative, if we take this, 3 times negative 1 is what? Is negative 3. Then negative of negative 1 times 0, that's still going to be 0. Then that's negative 0j. And then plus 0 times negative 1 is what? Is 0. And then negative of negative 1 times 2 is what? Negative 2. Okay, so that's going to be 6i. And then negative 3, that's negative of negative 3j is going to be a positive 3j. And then a positive 2k. And this is the normal vector. So taking this with the normal vector, and then you can choose any of the points. We decide to choose O. If we decide to choose Q, 0, 2, 0, right? If we decide to choose Q, what we are using now is alpha x minus x2 plus beta y minus y2 plus gamma of z minus z2. So what's that going to be? What's the alpha in this case? 6, right? So 6 into x minus, we have 0, 2, 0. X minus 0, and then plus beta. What is beta? Corresponding to b, right? 3 into y minus y2, and that is 2. And then plus gamma into z. And what's gamma in this case? 2, right? Into z minus, what's z2? 0. So that's going to be, and then everything equals 0. So that's 6x plus 3y, and then 3 times minus 2 is minus 6, and then plus 2z minus 0 equals 0. So that's 6x plus 3y plus 2z minus 6 equals 0. And that's equivalent to 6x plus 3y plus 2z equals 6. And this is the equation of the plane that is passing through those 3 points. So either things given to you is either you'll be given the 3 points and then you pick a particular point, let's say P. So what you're looking at is PQ and PR. If you choose Q, that means you're going to pick QP and QR, and then you get their cross products. That gives you the normal, and then with that normal, alpha I plus beta j plus gamma k, you now use the general equation alpha into x minus x1. You pick any of the points, alpha into x minus x1 plus beta into y minus y1 plus gamma into z minus z1, and that gives you, and then equate to 0. That gives you the equation of the plane, right? Or you'll be given the normal. In the case of the second question I solved, you'll be given the normal, just like this question that said the equation of the plane through 1, negative 1, 2, and you're given the normal, right? 2i negative 3j plus 4k. That gives us our alphas, beta, and gamma. Then into x, and then the point is given to you, x minus 1, y minus minus 1, and z minus 2, and that's the equation, right? So that's the end of this video. Thank you so much for staying through to this length, right? I'm very grateful. If you've not subscribed to this channel, do well to subscribe and turn on the notification button so that when more videos on these science courses are uploaded, you'll be notified. Thanks once again, and have a nice day.